Hello and welcome to part 6 of the DynaView PressurePro tutorial. We have covered all elements required to build pore pressure models and create reports to present the results. At the beginning of the tutorial we created a geomodel and you may have been wondering why. In this tutorial we will look at creating pre-drilled pore pressure models using the geomodel and also demonstrate how to create projected pressure models on the fly to predict changes in formation pressure during drilling. Let's start by opening the last project. The pore pressure functions only work on the master well, which is the well to be drilled. So let's change well number 2 to be the master well. Before we do anything else, we're going to add a seabed depth to the formation tops table and create a surface here. This allows for an upper bound to the model to ensure data can be projected through correctly whilst taking into account formation thickness. Go to the Formation Tops button on the top ribbon. In the dialog box, add a new formation top and call it seabed. Now go into each individual well and add the new formation, placing it at 73 meters for all wells. Double click on Type Cell in the first column and select the Mapped option to create a surface mapped to the contouring of another. Select Mapped from surface below and select Formation 1 as the surface to map to. We now have a fully bounded 3D geomodel with a surface at the seabed. We're going to simulate having a data set for a series of wells and a model built prior to drilling a well. Go to the PressurePro view and click on the Create Pre-Drill button. Select the Create Prog option. In the pop-up box, we select Remove All just to clear all the data out of that well to simulate starting a totally new well. We already have the elevation data, but change the default maximum MD to 1,350 meters. The next option allows us to select which offset wells to propagate data through the model from. This should generally be what are considered to be the most likely analogous wells, but we will simply create a composite by using all of the wells here. Click and drag to select all of them. Now we can enter in a well weighting. If a greater weighting is placed on a well, it will be more represented in the data, although it should be noted that the calculation already takes distance into account, so this is not necessary to use simply due to proximity. Select the lithology and the curves and create a Prognose lithology and curve set and select the well as vertical. We can see that DynaView has created a theoretical well. We could now build a full pore pressure model as Prognoses using exactly the same workflow as before, and then click on the Create Pre-Drill Model and select the Clear Master option. This will clear the master well of data and all the model that you have created and will put it into a prognosis. This approach comprises creating theoretical petrophysical characteristics based on an offset well and a geomodel. Now let's do the process again, but instead of selecting just the petrophysical curves, select the pore pressure curves as well. To select multiple curves, hold the Control key down while selecting. In this style of prognosis, we're simply mapping across the pore pressure curves from the offset wells. Now make this well the prognosis. Click on the Add View button and select the real-time log. Select the prognosis for the well selection and you can see that the full prognosis is still available for viewing. Further pore pressure templates are available through the Templates button. Now let's go back to the PressurePro view. We're going to simulate that we have partially drilled the well. Navigate to the Synthetics Curves tutorial dataset that has been provided. Click and drag the DSI and the PEX LAS files onto the project and assign the curves to the correct presets. Note that this drag and drop function makes data loading very easy during the drilling of a well, and once it has been done the first time, the presets will automatically populate according to the mnemonics in the files. However, this function will always only populate the master well data tables and cannot be used for offset wells. We now have a set of data down to 700 meters. We'll now create our own pore pressure model. In this particular case, rather than building our overburden from the real-time data or importing a curve produced with one of the offset well analyses, we'll make a synthetic one based on well number 1. Open the pore pressure dialog box and click on the overburden. Click on the wizard to add an overburden and select the synthetic option. Select well number 1 as the source well and enter a look-ahead distance of 300 meters. This wizard will also create a full synthetic pore pressure model, so we need to define a shale pick cutoff for the gamma ray. Leave the setting at the default 90 API and select the pore pressure model type as sonic. We now need to assign which curve to use from the offset well to propagate a synthetic curve from. Select the compressional and shear sonic curves and click the Create button. Before carrying on, let's assess what we have. The look ahead was set at 300 meters, so DynaView is projecting that far ahead of the bit, which is currently at 700 meters, and creating synthetic petrophysical curves propagated from offset well number 1. Now let's build the pore pressure model. Go to the Pore Pressure tab. Note that we already have a model here and it's purely synthetic. It's a model using just the synthetic sonic curve. Create a normal compaction trend for this model to see the pore pressure appear. Now we'll add the actual model for the well being drilled. Add a new model and make it a sonic model. Go and define a shale pick. The shale pick used on the previous model is a synthetic shale pick based on that 90 API cutoff that was given before. We will define a shale pick on the gamma ray and then an NCT on the sonic. We will simply add the synthetic overburden to the model for this demonstration. Change the pore pressure curve color to make it a little easier to distinguish. We can now see that we're running an actual model on real data and also a projection ahead of the bit based on offset data to help with risk mitigation and decision making during drilling. These synthetic models can give you a heads up of potential zones of increasing pressure coming up. Let's double click on a track and add a formation top. Notice that as we tie in the formation top, the model updates and shifts the synthetic curves accordingly. This means that any correlation carried out during drilling will take into account thickening or thinning compared to the offset well the synthetic curves are being derived from, and further assists in tightening up our understanding of the pressure going ahead in the well. It is at this point that we can truly leverage the geomodel for use as a real-time de-risking tool to help with decision making during drilling. DynaView PressurePro is unique in its ability to project a theoretical pore pressure ahead of the bit through a model which is updated on the fly and tied in. When a formation top is added, the model automatically deforms and the synthetic curves are updated, which then updates our projected model. If we can achieve a high correlation between actual and theoretical models, PressurePro provides the most powerful formation pressure related de-risking tool in the business to help with casing point selection or mud weight changes. This concludes the PressurePro tutorial. If you have any questions, please feel free to email us at techsupport@dynaview.info.